So performance characterization. This workstream comes under our quality product roadmap pillar. It's a workstream with a lot of complex objectives, which in previous community meetings we have defined and iterated. But I just wanted to spend a little bit of time now just refreshing our minds about what we're trying to achieve in this work stream, and how we're trying to achieve those goals. The main problem that this group is focused on is understanding how the Modular Loop platform performs on various different types of hardware and in various different scheme configurations, to process payment transactions, payment transfers. And to use that knowledge to inform our current and future adopters as to how best to design their infrastructure to cope with their changing needs for throughput on their platforms as their businesses evolve over time. Our very first priority was to understand how fast the current version of the Modular Loop platform is. We have a long-standing target of 1,000 transfers per second, being sustained for a period of 1 hour, with less than 1% of those transfers taking more than 1 second, with absolutely zero unexpected errors, and lasting for a period of 1 hour. We defined pretty early on that we thought, given that the Modular Loop transfer is a 3-stage process, that our testing and the way we think and understand the performance of the platform should take all 3 of those phases into account. So in the workstream, we think of a transaction, a transfer, an operation that we're measuring in terms of those 3 stages. There is value in understanding how each one of those stages perform individually and how they contribute to the overall performance of the system. Obviously, if we have a bottleneck in any one particular part of those flows, then that will contribute to an overall drop in end-to-end performance for the platform. So we're trying to be smart about how we measure and monitor the performance of the platform while we're testing it, to help us understand where bottlenecks might be, so we can focus our efforts on resolving those bottlenecks. We have given a considerable amount of thought to how to generate sufficient and appropriate load to test the platform. There are a number of possible approaches we may have taken. We've tried to be as realistic as possible by understanding the way traffic in the real world across a payments system may vary throughout the course of a business day, or even over a business week or business month. You can understand that some periods of the day might be much more active than others during working hours, for example, and some times of the month might be more busy, given that some employees receive their monthly salary towards the end of the month or the beginning of the next month. You can understand how the traffic patterns may vary over time. So we've tried to take those factors into account when designing our test scenarios. The Modular Loop project is targeting nation-scale adoption, which means the way we test the platform has to be representative of that type of deployment. In those schemes that are being built and that we're trying to build in the future, the types and capacities and throughputs of the various participants in the scheme is likely to be different and uneven. You can imagine that some DFSPs, mobile monies, for example, might be an awful lot more busy than some microfinance or microloan type organizations. So we wanted to be sure that we designed a a test architecture, a test suite that would realistically as possible simulate some of these differences in the scheme architecture. So a considerable amount of thought has been given to that. Obviously, when running any sort of performance test, we have to be careful that when we repeat the tests, we remove as many uncontrolled variables as possible. That means being able to know with confidence that the hardware platforms that we're running the tests on don't change over time. This is particularly difficult in cloud, where you might be sharing resource with other cloud customers. There are some mitigations that we've given a considerable amount of thought to, such as pre-provisioning the number of IOPS that, for example, AWS will allow us to run. But our general approach is to remove as many uncontrolled variables from the test environment as possible. When it comes to toolchain, previously, and I say previously, going back well, probably more than 3 years now, some of the early performance testing that was done on Moduloop was using a toolchain based on JMeter and the SDK scheme adapter. But there were some issues with that this workstream has tackled and tried to work our way around, particularly the asynchronous callback-oriented nature of the main transfer processing flows. Made it quite tricky and difficult to isolate different parts of the system. So we used the SDK scheme adapter as a front end in front of JMeter to work around that limitation. But obviously, you're introducing another component into the system there, the SDK scheme adapter itself, which had some interesting performance characteristics itself, and it not being a very simple flat tool with some distributed cache and messaging tools involved in that process. It was leading to some complexity and hiding some of the underlying performance characteristics of the system that we were actually trying to test. So we've recently, well, I say recently, over the last 1.5 PIs, we've moved to a platform called K6, which is a slightly more modern, newer, up-to-date test framework. We have a suite of performance tests now for K6, which allows us to eliminate some of that complexity and make sure we focus our efforts and understanding on the core components of the platform rather than the integration layers around the outside. Once we'd understood where we were with the basic performance of the system and we had some numbers for the 3 transfer phases, we started to push beyond those limits and understand where the bottlenecks were. And as Sam alluded to in his previous couple of presentations, a number of bottlenecks have been identified and eliminated already. I want to call attention to these secondary priorities of this work stream. I've highlighted here our priority 2 and priority 3. Just recently, we've made a decision to swap the priority of these. So what you're seeing on your screen now is priority 2, used to be our 3rd priority. What you're seeing as priority 3 used to be our 2nd priority. So given the improvements that have been made in the release process and feedback we've been receiving from our product and market-facing community members, we've realized that it's possibly more important to communicate upon our releases the performance that an adopter can expect from any particular version of Moduloop. So going forward, we have decided to spend more of our immediate time and energy in running those repeatable apples for apples type tests as part of our release process. So when we publish our release note, we can also include a performance test report that will give adopters an understanding of the characteristics of the platform in that particular version. That also gives us an ability to monitor how the performance of the platform evolves over time from release to release. And then our final priority, which we're kind of expecting we might get around to in the next PI. I'll talk a bit more in the next slide or two about where we're going next. But we do eventually want to have performance testing running as part of our CI pipelines. So in theory, every code change in a Mojo Loop repository would have a performance test underlying that would show a contributor, a developer, before they merge their code into the main branch, before it becomes incorporated in a release. Everybody can see and understand how those code changes affect the performance of the component and how that component contributes to the overall performance of the platform. So what have we achieved against those objectives in this PI? Well, so far we've tested, as I said, the discovery, agreement, and transfer phases. We have captured a whole bunch of results and analyzed those. We have implemented some quick fixes, identified where some of the immediate low-hanging fruit bottlenecks were. Those fixes have been done. They've been incorporated in recent releases. That is ongoing work. So it's possible that we'll see more performance fixes in future releases. We're expecting that to become part of business as usual. However, we haven't made a great deal of progress this PI beyond that, just purely because we haven't had much resource available in this workstream. We desperately need more people to come and help us who have infra experience or Mojo Loop core experience, anyone who has performance testing experience and time and energy they want to contribute to the workstream, even if it's just brain time, thinking time, or helping us document. You don't need to actually be spending a huge amount of time running tests, but we do need more help. So please reach out if you possibly can. In a little bit more detail, the K6 test suites that I mentioned have evolved slightly over the course of the PI. Those tests are in the core test harness repository. So if you want to go and have a look, see where we are with those, possibly contribute, please go and have a look in the core test harness repo. They're pretty obvious. They're in a place called K6. If you can't find them, please reach out to me on Slack. So far, we've run the tests on a few different hardware configurations between
our Mojo Loop.
Hello. We've run the tests on a few different hardware configurations across cloud and bare metal. And we've captured an awful lot of results. Some of those results have been published and they're available in GitHub. If you have a look at that GitHub repository that's linked down at the bottom of the slide there, you'll find a summary of the tests that have been run so far. We do have quite a volume of tests that have been run where we have gathered results, but we just haven't published the results yet. We just run out of time and resource, and the folks that were contributing on the workstream have been pulled off in other directions over the last month or so. But we are expecting to publish those results quite soon. But as per our #1 priority of the workstream, and I suppose you could say this means the workstream has at least met its highest priority objective so far, was to identify those immediate bottlenecks in reaching that 1,000 TPS target. Those fixes have been applied and they have been released. But as I say, that's an ongoing process. So what are we going to focus on in PI 25? Well, we think it's important to clearly define and document a standardized framework for how we measure and talk about the performance of Modular Loop. The testing that's happened so far in this work stream has been across the 3 transfer phases and end to end, as I say, but there's no up to now, there's no clear statement or documentation about how those tests should be run. Every test run has detailed documentation about the conditions of the test. But what you'll notice if you look at that repository is that during some of the test runs, those conditions are different. As we've started to understand some of the hardware requirements for particular parts of the transfer flows, we've optimized them by running them on hardware that might be more suited for that particular workload. So what we want to do is settle on a particular hardware configuration for all of those 3 transfer phases and the system as a whole, not just on single nodes, but across clusters as well. We want to clearly document the conditions under which these tests should be run. So that will allow not just the release workstream to run repeatable apples for apples comparison tests when we do releases, but also anybody who wants to come along and reproduce those tests. I'm a strong believer in following scientific method when it comes to software engineering. So having reproducible tests is very, very important. So that's our number 1 focus from today moving forward, is to document and standardize what that framework is, what those test conditions should be. So going forward, we have results that are comparable between releases and between code changes. The next step from that is to build some tooling that enables those repeatable tests to be run as part of our release process, as part of the automation that Sam was talking about. So the CI script that generates the PR and performs all the other roundup tasks as part of the release process, we want to have that automatically spin up a test environment, run the performance test suite, capture those results and present them in the release notes as well. I think that will be a significant step forward for us to be able to talk about the performance of the platform and understand in each release how performance is varying based on the new features that are being added or bug fixes, understanding the implications of those on the performance and overall throughput of the platform is important. So that's quite a high priority for us. So I think I already mentioned our current lowest priority is to have those lower component level tests running in the CI pipelines. That's a nice to have for us at the moment, I think. As long as we have a repeatable process that could be manually triggered at those bigger quality gates when it comes to release, we can see the performance changes that get rolled up into a particular release. So we still have enough information to be able to spot if we're potentially rolling out a performance regression or a change that's had a very negative impact on performance, and that would tell us where we need to go and refocus our efforts before making a release that negatively impacts performance. But obviously, the earlier we can detect those performance regressions in the normal engineering workflow, the better. But we just don't have enough resource to do those number 2 and number 3 in parallel at the moment. If we can find some more resource to contribute in PI 25, then we'll certainly look at doing that as a matter of urgency. So I'm not sure how long I've been speaking for. It may well be well ahead of schedule, in which case I apologize to Simeon for messing up your schedule. But just before I hand back to Simeon, We have struggled for resource this PI, but the people that have contributed have given a lot of their own personal valuable time to the project, and we're very grateful for everything you've done so far.